All right, so we're starting our new chapter today. This first section here is called Exploring Quadratics, because we're going to try to learn a little bit about quadratics on our own before we get into, graphing them. So let's look at this first sentence right here. It says, in this chapter, we will be exploring quadratics. The graph of a quadratic is called A. This is what quadratics look like right here, okay? So I'll just trace the one in E really quickly so everyone can see it. It's this right here. It has arrows on the end, but these are screenshotted, so it chops off the arrows. That's what it looks like. Does anyone know what that's called? It's called a parabola. So it is called a parabola. So if you refer to a parabola, I know you're talking about a quadratic. If you're talking about a quadratic, I know you're talking about a parabola. It says we will start with a quadratic in the form y equals ax squared and use Desmos to discover the effects that a and c have on the parent function of y equals x squared. So what I want you to notice is that this is called the parent function. This is without any transformations done, meaning it's not moved right, left, up, down. It's not reflected. It's not, gotten wider. It's not gotten narrower. So what you're going to notice about all quadratics is that they have an x squared in them. So notice the x squared, x squared, x squared there. If it was a line, lines do not have squares in them, right? So we can tell that this is going to be a parabola. And if I saw y equals x plus 5, I know that this is not a parabola. This is a line. Now it's a parabola. Everyone see that? Okay. So it says, how does A affect the graph? How does C affect the graph? So I'm only going to do one with you, okay? But you're going to have to do this exploration on your own and fill that in on your own. You can check my key with yours when you are done. So here's the first problem. If you click on the Desmos links, what you need to do is you need to click on Desmos. The code will already be in there. You're going to continue without signing in, enter your name, and then it'll bring you to this first problem. So what I'm trying to do is I'm trying to get this red parabola to fall on top of that dashed blue parabola. That's the goal, okay? So what I'm going to do is I'm going to manipulate A and C here on the graph. So what you could do is you could hit the play button to the left to see what happens when you change A first, or you can just start changing A by moving it yourself, okay? So as you can see, what happens when I make A bigger, the graph is getting narrower. When I make A smaller, the graph is getting wider, right? So if I go over here, it's getting wider and wider. Now, if I make A negative, it's going to also flip it, okay? So I need to make it wider, so I'm going to guess it's about there for now. But then also I need to change C. So if you notice, I need to move the vertex of the parabola, which is at 0, 0. I need to move it down. So I'm going to start by taking C and making it bigger. Notice that it starts moving it up, so I don't want to do that. So I need to move C down. I'm going to say, okay, that's down 2. Oops, what happened there? And I'm down 3 now, and it lined up, okay? So as you can see, what's going to happen with C is that C is going to move your graph up and down. A is going to make your graph wider, narrower, and if it's negative, reflect it. So now I'm just going to adjust A a little bit more. If you noticed, it was perfect, and then I let go, and it kind of moved a little bit. That's 2. If you're ever having trouble getting the number, and you're like, I know it's supposed to be whatever, you can click on it, and then hit your keyboard, and you can hit the backspace and change it to whatever you need to. Okay, so what I've discovered here is that C is going to move my graph up and down, and A is going to make my graph wider and narrower. If A is negative, then it's going to reflect my graph. Okay, so let's keep that in mind here, and you can fill that in here in your notes. I'm not going to because I want you to put it in your own words. All right, so it says match each function with the corresponding graph. So number 1 is y equals negative x squared. So I am looking to see how my parent function y equals x squared has changed. There is a negative in front, okay? So remember when we said that we made the a value, because that's what we're doing, we're making the a value negative, it is going to reflect our graph. So what we're doing is we're looking for a downward facing graph. So A is out, D is out, E is out. It's going to be B, C, or F. Now, if you notice, there is no C value on this. This is plus 0. So our graph is not moved up or down. So we have to realize that the vertex is still at the center, 0, 0. At the origin, that is. So this is B. Next one, y equals x squared plus 5. This is moved up 5. Still facing upward. So I'm looking for a parabola that is, vertex is moved up 5. Right here. And then still facing upward. So that is D. E, or sorry, number 3, this is down 5. So I'm looking for a parabola that's still facing upward. That's moved down 5. That'd be this one right here. So that's E. And then finding this last one here, this is moved up 5. But notice there's a negative in front, so it's also reflected. So I'm looking for up 5 and facing downward. So here's up 5 and then facing downward. That'd be C. Okay, so next it says, how would the graph of y equals 2x squared plus 5 be different from the graph of y equals x squared plus 5? How would they be different? So if you notice the difference in what they look like here, there is a 2 here, there is no 2 here. So how would this graph be different from the second graph? Now, they are both moved up 5, so that's not different. But there's a coefficient of A, so what did the 2 do? If you don't remember, you can look back at Desmos. What the 2 did, if I make this a 2, it's going to make the graph get narrower, okay? So I'm going to say, let me go back to my notability here, is that this graph, this parabola, is narrower. This quadratic is narrower, either one. So what you have to get through your head is that the 2, which a lot of people think like, oh, 2 means bigger, right? Because it's doubled. That's not what it means. It is going to be narrower. Something small like a half or a fourth, that would make your graph wider. Okay, so what we're going to do is we're going to go through each one of these. And this is our function rule, so this is our quadratic. Notice that they're all quadratics because here's an x squared, x squared, x squared, x squared, x squared. The first question I ask you, we're going to look at the first one. I'll call this number 1. Does it open upward or downward? So you're going to look at the A value in front and see if it's positive or negative. Since it's negative, it's opening upward. Now it says compare to y equals x squared, is the graph wider or narrower? So you're going to look at the A value. That's a 2. Remember, 2 is going to make your graph narrower. Last but not least, is the graph translated up, down, or neither? So you're going to look to see what's added on the end. There's nothing added, so this is neither. It's not moved up, nor is it moved down. All right, let's look at the second one here. Up, down. Which one is it facing? There's a negative in front, so that is moving, or so it's downward facing. And if I just realized that there's a negative in front on the first one and I wrote up and I meant that it's facing downward. Oopsies. Okay, next one, there's a 5 in front. So 5 is a number bigger than 1, just like 2 is, so this is also narrower. Now I look right here and there's a -1 on the end, so this is moved down 1. All right, let's try number 3. Does the graph open up or down? If you look in front, the A value is positive, so this is going to be opened upward. Now, if you look at the A value itself, which I'm going to highlight in green here, it is 1/4. 1/4 is a number that's smaller than 1. It's in between 0 and 1. So this is going to make my graph wider. All right, so a lot of times, once again, you're thinking 1/4, oh, that's smaller than 1. So narrower. No, it's the opposite of that. All right, then I'm going to look on the end right here. Nothing's happening, so this is neither. All right, next one I have a point. Oh, sorry, first is it up or downward? That's a positive number, so that's up. 0.6 is less than 1. It's in between 0 and 1, so this is wider. And then the +3 means it's moved up 3. Last but not least, there's a negative in front here, so this is facing downward. The A value is 1, so this is the same is x squared. It's not wider or narrower. And then on the end here, there's nothing. So this is not moved up or down. So this is neither. All right, that's